Hello and welcome. Thank you for joining us for our 16th Electron mission and our very first attempt to recover a first stage as part of Rocket Lab's efforts to make Electron a reusable launch vehicle. You're looking at a live view of Rocket Lab Launch Complex 1 in Mahia on New Zealand's east coast as we count down to a 3:20 PM New Zealand time liftoff. Today's launch is our 6th mission for the year, a mission we've aptly dubbed Return to Sender. I'm Ariana Ryan and I'm a quality engineer in the propulsion team.
And I'm Max Muncy. I'm a data analyst here at Rocket Lab, and it's great to be back with you for our 16th launch. We're in the final stages now of launch preparations as we count down with 17 minutes remaining on the clock to lift off for this mission. Electron's primary mission today is to deploy a diverse range of payloads to orbit. Inside Electron's fairing, we've packed in 30 small satellites from customers in the United States, France, and New Zealand. Before we get into those customers and satellites though, let's talk about reusability. Today's mission marks a major step in our goal of turning Electron into a reusable rocket, and is our very first attempt at recovering an Electron booster after launch. Electron's first stage has been expendable on all 15 missions to date, but for the first time we'll be trying to bring the stage back underneath a parachute. We're aiming for a soft splashdown in the ocean, several hundred kilometers downrange from LC-1, where our recovery team will extract it from the water and bring it back to our production complex for inspection. While the ultimate goal is to bring back a fully intact stage, today's recovery attempt is very much a test.
Yeah, so regardless the state the stage comes back in, our team will come away with lots of data and information for our future recovery efforts. And, as a reminder, today's recovery effort does not include an attempt to catch the booster mid-air with a helicopter. That will come in future attempts once we've completed successful parachute re-entries. So, right now our recovery team is ready and in position in a vessel in the Pacific Ocean, close to where we're expecting Electron's first stage to splash down at about 8.5 minutes or so after liftoff. We'll try to bring you live footage from the camera on board as the booster begins to make its descent, and we'll stick with the feed as long as we can, but we are expecting a telemetry dropout as the stage reaches 30 kilometers altitude on its descent. To tell us more about how we're approaching rocket reusability with Electron, let's hear from our CEO Peter Beck and the recovery team here at Rocket Lab.
It's been enormously fun along the way. This has been the best project almost, doing these big scale tests where there's lots of energy and it's been super fun. We set out at Rocket Lab to try and recover the vehicle, primarily to increase production. And first I didn't think it was feasible to do with a small launch vehicle, because if you look at all the traditional approaches, they're just not going to work. You don't have the propellant margins in a small launch vehicle. So we had to look at different approaches, and as we started to pull real data from real flights, it became obvious that there was an approach that could work. It was a little bit unconventional, and we started off down that path.
So after separation, it will coast on up to apogee, do a flip, come in engines first, accelerates for a while as it comes in, and then decelerates, getting very hot in the process. Once we're down to about Mach 1.5, we'll activate a mortar, which will deploy a drogue parachute. That will slow it down further, and then when we're down to 2 or 3 kilometers altitude, we'll extract the main parachute, which is a big 18-meter ring sail, and that will slow us down to a fairly modest velocity of about 10 meters per second, where we'll take a splash in the ocean. A lot of it comes down to just the size and mass constraints that we're dealing with. Trying to package a whole load of extra equipment, mortar, extra parachutes, reaction control system, gas bottles for that, and the additional electronics into a volume that's already very tightly filled with the second stage rocket engine and battery compartment. That was probably our biggest challenge.
The most important thing that we're trying to achieve here is just to get the stage down to Earth in one piece, or as close to one piece as possible. So we won't be trying to scoop it out of the sky with a helicopter. We have demonstrated that we can do that, so I'm not too worried about that. The real challenge for us here is getting it through the wall, getting it under a parachute, getting it decelerated, and gently touching down into the ocean, where we'll go and pick it up with recovery vessels.
Okay, the main parachute on the stage is a ring sail parachute. This was a design that NASA used way back at the sort of dawn of the space age, the same design used for the Mercury and Gemini and Apollo spacecraft.
It's much easier to deploy, especially at high speeds, which means we don't need a complicated parachute system to get it out there. So that's why we've chosen ring sail parachute for now, as opposed to a kind of gliding parachute that we looked at previously.
It's kind of like a CSI scene, where we really start to peel back the onion and understand exactly what's happened. There's nothing like actually having a flight article that's returned to understand the margin here and the margin there, and which bits really worked well and which bits are just roasted up completely. If we get the stage back, we'll have a really good idea of how much work we've got ahead of us. Recovery for our customers is really about making sure that there's more launch opportunities available. If we can recover a stage, we can open up many more launch opportunities and create a much more flexible environment for our customers to pick and choose which flight they want to get on, ultimately try and lower the cost, and just make launch even that more prolific.
So as you heard Peter Beck mention there, our ultimate goal for this attempt is to fish an intact booster out of the ocean that we can transport back to our facilities to check out what we've got. Keep an eye out on our social media channels for updates on what we find at the end of this live broadcast and in the weeks to come.
So we're coming up on T-minus 12 minutes, so let's check in with the launch director, Sean DeMello, and the rest of the team for the final go, no-go poll.
For launch. Stage.
Stages go.
Avionics.
Avionics is go.
AFTS.
AFTS is go.
GNC.
GNC is go.
Beacon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
BLS.
BLS is go.
RSO.
RSO is go.
MET.
Mid is go.
MM.
is go.
Recovery.
Recovery is go.
LD-Sub.
LD-Sub go.
Executive.
Executives go for launch and recovery.
Go no go sequence complete. We are at T-minus 11 minutes, 37 seconds and counting. We are go for terminal count starting at T-minus 10 minutes. From this point on, 3-word hold procedure is in effect.
And there you have it. Our operators and launch director have confirmed Electron is primed and ready on the pad at Launch Complex 1. Now to the customers on board this special mission. The satellites for this launch span a range of operations, from tech demonstration through to maritime surveillance, communications, and education, as well as a final special guest hitching a ride to space. Today's mission will launch the APSS-1 satellite from the Auckland Program for Space Systems from the University of Auckland here in New Zealand. This is a particularly special payload because it's New Zealand's first student-built satellite. APSS-1 is designed to measure electrical activity in the upper reaches of the Earth's atmosphere, right at the edge of space, a region known as the ionosphere. Because the ionosphere is ionized by solar and cosmic radiation and is affected by phenomena such as solar winds, it is uniquely reactive to the changing magnetic and electrical conditions. That means it affects radio and GPS signals here on Earth, including television, internet, and telephone communications. But scientists are also curious to what extent and how the ionosphere is affected by geophysical activity here on Earth, including whether the electrical disturbances that occur in the ionosphere might be correlated with earthquakes. More than 26 students have worked on this satellite across several years, so we're very proud to be delivering it to space today. To support innovative student projects like this one, Rocket Lab is providing the launch service to the Auckland Program for Space Systems at no cost.
Next on the list is the drag racer payload from US company Tricept, which is designed to test new tether technologies that could accelerate spacecraft re-entry and reduce orbital debris at the conclusion of space missions. Tricept's payload includes two 6U smallsats, one with a tether drag device measuring 70 metres long and the other without. Next up, we're welcoming a return customer back on board Electron following the first successful deployment with Rocket Lab in August of 2019. French company Unseen Labs. This launch includes two of their satellites to grow their maritime surveillance constellation. Both of these small sats independently and precisely locate and fingerprint radio frequency emitters all around the globe, day or night in any weather conditions, and without requiring any special embarked tracking device.
That's right, and 24 of the satellites on board today's mission include the latest quarter-U Space Bee satellites from Swarm. These Space Bees are designed to provide affordable satellite communication services to IoT devices in remote regions around the world. And finally, fans of the game Half-Life will recognize our very special guest on this mission from Valve co-founder Gabe Newell. I'd like to introduce you to Noam Chomsky. That's right, we are launching a garden gnome to space, or to be more precise, a mass simulator in the shape of a garden gnome. This little guy right here is a replica of the one sitting inside Electron's fairing, which is about to head to space. Manufactured with support from the Weta workshop, this tiny astronaut will finally complete his achievement for real. Because we have a no gnome left behind policy here at Rocket Lab, Mr. Chomsky will remain attached to the kick stage and deorbit with it as it falls back to Earth.
Not only does this mission serve as a tribute to the innovation and creativity of gamers worldwide, but Gabe Newell is personally donating $1 to the Pediatric Intensive Care Unit at Starship's Children's Hospital for every person who watches the launch with us today. So thank you so much for tuning in. And thank you to all of our customers for choosing to ride on Electron. We couldn't ask for better mission partners, and we're proud to be working with you all.
Avionics LD on mission.
LD avionics.
Proceed with sequence 51, AFTS enabled for flight.
Proceeding with sequence 51. AFTS is green and enabled for flight.
The 18-metre tall Electron is made of 2 stages to get to orbit and a 3rd stage for precise deployment of the satellites on board. Electron's 9 Rutherford engines at the bottom of the 1st stage do the heavy lifting to space before the 2nd stage separates to carry on the mission. The 2nd stage is powered by a single electrically pumped Rutherford to get to orbit before Electron's kick stage takes over and carries out the final leg of the journey to deliver the satellites on board to their specific destinations. Once stage separation occurs, approximately 2.5 minutes into the mission, Electron's 1st stage booster, which you can see on your screen there, will begin its descent back to Earth, and it's this part of the rocket we'll be attempting to recover on the mission today.
To support this mission's recovery attempt, we've added some extra hardware and components to Electron's 1st stage. Here to tell us more about what's been added to Electron is Dominic Fu, a familiar face and integration technician whose team assembled the rocket and the recovery hardware. He joins us now from Rocket Lab's main production facility. Dom, what can you tell us about the differences on the 1st stage for today's mission?
Hey Max, that's right. The 1st stage on Electron is a little different on this mission, but it's not just the paint job that's new. I'm standing on the factory floor here at one of our production complexes, and behind me there are about 7 Electron rockets, all lined up for missions later this year and early next year. Right here is where the 1st stage for today's mission was fitted with recovery systems that will hopefully enable us to bring the stage back under a parachute today. Now approximately 2.5 minutes after liftoff, at an altitude of around 80 kilometers, Electron's 1st and 2nd stages will separate. Electron's 2nd stage will continue to orbit, where the kick stage will separate and deploy the satellites. So up until now, we're following a standard mission profile, but next is where it gets interesting for recovery. With engines now shut down on Electron's 1st stage, our reaction control system will reorient the stage 180 degrees to place it on an ideal angle for re-entry, designed to enable it to survive the incredible heat and pressure known as the wall during its descent back to Earth. Now on the recovery booster, the RCS thrusters are located near the top of the vehicle, highlighted on your screen. When Electron decelerates below Mach 2, a drogue parachute will be deployed to increase drag to stabilize the 1st stage as it descends. In the final kilometers of descent, a large main parachute will be deployed to further slow the stage and enable the controlled splashdown. Our team on the recovery vessel will rendezvous with the stage after splashdown and retrieve it for transport back to this production complex for inspection. Once we get the stage back to the factory, we'll inspect every inch and use that knowledge to inform our next recovery effort. It's going to be such an amazing mission to watch that I'm just going to wrap this up right now. I'm going to join everybody else at Mission Control. Back to you, Max and Ari.
Thanks very much, Dom. The recovery team might be leading the program to bring back an Electron, but almost every team across the business has been involved in getting us to this point. So it's exciting to be just minutes away from liftoff for this very special mission. A quick reminder that we will have live video of the beginning of the recovery process. We're expecting the feed will cut out as Electron goes through the wall and eventually drops out of telemetry range. We'll be sharing photos of the recovery effort on the water as soon as they're available. So, with just 2.5 minutes left in the count, we're going to hand you over now to listen in on comms from Mission Control for the final minutes until launch.
All stations, LD on mission cord. We are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
AV bits are on internal power. The vehicle is fully on internal power.
Lux load is complete. System is in recirculation. Anti-gas ring disabled.
Stage 1 and Stage 2 tanks are pressed.
High flow engine purge is enabled. Deluge is activated.
T-minus 20 seconds and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2.
Stage 1 propulsion is nominal.
Entering stage 1 burnout detect mode.
And we have liftoff of Electron from Rocket Lab Launch Complex 1. We're just 50 seconds into flight, and you heard the call out on comms there that the mission is continuing nominally. So Electron will approach max Q along its trajectory, otherwise known as maximum aerodynamic pressure.
Approaching maximum dynamic pressure. Past maximum dynamic pressure.
And there goes the call from our operator on console. Electron has cleared max Q. Propulsion is continuing to look good on the path to orbit.
Stage 1 guidance is nominal.
Coming up next in the mission timeline is main engine cutoff, also known as MECO, as Electron's Rutherford engines power down so that the first and second stages of the vehicle can separate cleanly. Following that, the vacuum optimized engine on the second stage will ignite to carry the satellites on board further into space, while Electron's booster will begin to fall back to Earth, marking the start of our recovery attempt. The team on the recovery vessel will now be furiously tracking its return telemetry.
MECO confirmed.
Staging.
Stage to ignition.
Recovery telemetry nominal.
Flight analyst, recovery LDN mission cord, execute sequence 53, stage 1 recovery operations.
Computing landing zone.
MECO is confirmed, and so too is the startup of the second stage Rutherford engine. With the separation of stage 1 and 2 complete, we'll try and stick with both views as long as we have them. The trajectories are looking good so far while we're awaiting fairing separation.
Fairing separation.
And there goes the fairing, and welcome to space, Mr. Noam Chomsky.
Stage 2 propulsion is nominal.
If you're just tuning into the broadcast for our 16th Electron launch, we've successfully lifted off the pad at LC1 in New Zealand and have had a successful MECO, stage separation and stage 2 ignition. Electron's second stage burn is in progress as we hit 4 minutes and 17 seconds into flight.
HV discharge nominal.
Stage 1 apogee.
Stage 2 guidance is nominal. Altitude is 170 kilometers and speed is 1 point.
A couple of months ago, some of you may remember we conducted the maiden flight of our Photon satellite, which we called First Light, during our 14th launch. The kick stage, which you can see Mr. Noam Chomsky mounted to here, forms the basis of our Photon satellites. By offering launches and satellites as a bundled service, we make it easier for small satellite operators to get to space, removing the need for them to source satellite, launch, and ground stations separately.
Throttling down. Stage 2 guidance still nominal. 200 seconds remaining.
Just a quick update for you all here. Electron's second stage burn continues nominally at a velocity of 14,000 kilometers per hour and an altitude of 190 kilometers. It looks like we've still got visual of stage reentry as well, and it feels good to be back in space.
We're now at T plus 6 minutes and 8 seconds into flight, and both our second stage burn and first stage booster re-entry are looking stable. Next up will be battery hot swap to continue supplying power to the second stage engine and systems. Let's listen in for that call.
AFT is saved.
Stage 2 propulsion is nominal.
Stage 1 re-entry.
We've had battery hot swap confirmation, and we're about a minute and a half away from when we expect Stage 1's drogue chute to deploy. The ride is going to get a little bumpy on the way back down, with the booster reaching several times the speed of sound on its fall back to Earth. A reminder that we'll stick with the video feed as long as we can, but we do expect to lose it soon. And as expected, it looks like we've lost video connection to Electron's booster there. We should expect the first stage's main parachute to deploy at about 8 minutes and 44 seconds into the mission. If we get that confirmation while we're still on the air, we'll be sure to share it with you. Otherwise, check in on our social media channels for further updates when we end the broadcast. Now let's listen in for the call while we wait for Stage 2 separation.
Guidance is in terminal, 20 seconds remaining.
Seeker confirmed.
Nominal transfer orbit.
And as you just heard from the team in Mission Control, the engine on Electron's second stage has shut down and the kick stage has separated. So Noam Chomsky finally gets his day in space. In approximately 45 minutes or so, the payloads will be deployed to their precise locations using our innovative kick stage. So here's a quick rundown of how this additional stage works. Electron's second stage takes us to an elliptical orbit where the kick stage then separates. From here, the 3D printed Curie engine on Electron ignites to propel the stage and its payloads to a circular orbit for deployment. Using a cold gas reaction control system, or RCS, the kick stage accurately points itself to deploy each satellite to a precise and individual orbit, even on rideshare missions with multiple satellites like this one. Once the satellites are deployed, the Curie engine reignites, propelling the kick stage to a lower orbit where it will be dragged into the Earth's atmosphere faster, leaving behind no space junk in orbit.
We've just had confirmation of successful drogue chute and main chute deploy. We can't wait to share we can't wait to share these photos of recovery in the coming days. So with that, we're going to end the launch broadcast here ahead of that final sequence. We'll be sure to let you know as soon as we can about our recovery efforts and of course payload deployment. Thank you once again to our customers for choosing to launch on Electron, and thank you to each and every one of you for tuning in to watch this very special mission. I'm Ariana Ryan.
And I'm Max Bunsey, and this is Rocket Lab Mission Control, signing off.